Oh, here we go. Here we go. Well, the whole period A, it's a Thursday afternoon. It's just weird because I'm recording this on Saturday the night before Easter, Holy Saturday. And I'm looking at my screen and I'm seeing my voice is off. So I don't know how this is going to come through, but let's give it a shot. So hopefully you had we've already talked about it. You had a great vacation, Easter. It's Thursday, even though Easter hasn't happened. I'm like in a time travel thing. All right, but you don't care about that. You just want me to share the screen and let's see what I've got for you. Here it is. So today, which is Thursday, April 28th, day 3, we're going to discuss page 5. We're discussing page 5. 1 through 17 odd. So we're going to do that and then more practice of the same. Here's your homework, page 6, 1 through 10. So last page of that packet, page 6, 1 through 10 is your homework. Let's go to page 5, 1 through 17 odd. So where is it? Where is it? Who? That might have been it. Here we go. All right, so 1 through 17 odd, solving rational equations. So remember the steps? The steps were to first factor all denominators, right? So factor all denominators. And then it's find the LCD, multiply each term by the LCD over 1. And then you get some cancel. And step 5 is solve, which could involve quadratic formula and all kinds of crazy, wacky stuff. So let's go. Let's do this. So number 1, factor all denominators. C's can't be factored. C plus 3 can't be factored. Find the LCD. As we said, C is a totally different animal than C plus 3. So our LCD, we need them both. We need C and C plus 3. I'm going to run out of room, so I'm going to go to the next page. 5 over C, 2 over C plus 3. So our LCD is C times C plus 3. So we multiply the entire LCD over 1. Will that move? Yeah, look at that. So you multiply by that, and then same thing here, C plus 3 over 1. So unlike when we do addition and subtraction, where we just multiply by the missing term, so to speak, here we multiply by the entire LCD over 1. And the good news is things will cancel. So step 3, multiply each term by the LCD over 1. Step 4 is cancel. So let's cancel this C, cancel this C, and over here the C plus 3s. Then you multiply. C plus 3 times 5 is like this. And over here I just have 2C, right? So is that step? Well, step 5 is probably should be multiply, and step 6 is solve, I guess. So we multiply 5 times C plus 3, 2C, and solve. And pretty easy to solve this one. 5C plus 15 equals 2C. C is on one side, So what do you get? C equals -5? I think so. So that one's not too bad. All right, next one. 7 over m plus 1, 12 over m plus 2. 7 over m plus 1 equals 12 over m plus 2. Step 1, factor all denominators. They're already factored. They can't be factored, so we're good. Step 2, find the LCD. Well, m plus 1 is a whole different animal than m plus 2, so you need them both. You need them both. So our LCD is m plus 1, m plus 2. So here we go. I love the smart board. I don't have a smart board at home. I have a smart notebook. So you can do things like this. Let's shrink it down so it fits. Beautiful. Okay, so you multiply by that entire LCD over 1. Over 1. Next step is to cancel. I can't get to other colors here. There we go. Never mind. Cancel m plus 1, m plus 1. Over here, cancel m plus 2, m plus 2. Next step's multiply what you got left. if you've done it right, whoa, that's wild. It just disappeared. If you've done it correctly, your denominator is 1. The whole idea of multiplying by the LCD over 1, I don't know what's going on here, is that the denominators will cancel. I don't know if I hit magic pen or what, text pen. Oh boy. So let's do that again. It is. I'm liking it. Time traveling and crazy things are happening. So cancel. M plus 1, M plus 1, M plus 2, M plus 2. See, your denominator is all 1, so you don't need a denominator anymore. Multiply 7M plus 2 equals M plus 1 times 12. Write it like this. And now that's easy to solve that. Do I really even need to go through this? M's on the left, numbers on the right. So M equals 2 over 5, I think, positive 2/5. See if that makes sense. I think I did that one right. Okay, what's next? Boy, do we have to factor any of these? No, we didn't have to factor any of these denominators. That's not good. How about on page 6? Let me look at page 6. Yeah, on page 6, you have to do some factoring. So these are pretty easy. So number 5, y over y minus 2 equals y plus 1 over y minus 5. So since I haven't officially assigned this yet, I'm just realizing now that page 5 is easy because you didn't have to factor any denominators. We'll get into that in page 6. But so the LCD is y minus 2, y minus 5, right? Those are totally different binomials. So you need them both. So you multiply by that over 1 here, and same thing here. Okay, and we cancel. Y minus 2, y minus 2. I'm left with y minus 5 times y. Do it this way. Cancel y minus 5. I'm left with y minus 2, y plus 1. Okay, it's a little more interesting now. Distribute here, y squared minus 5y, and FOIL here, you'll end up with this when you collect like terms and all that. Okay. We've got quadratic, alert, alert. We got y squared, it's quadratic. How do we get solve quadratics? Get everything on one side, 0 on the other. And the good news here is when I subtract y squared, they go away. And now I have this, no more quadratic, simple linear equation. Y's on one side, constants on the other. Life is good. Negative 4y equals negative 2. Divide by that negative 4. I'm going with y equals 1/2, positive 1/2. Okay, what else we got here? More of the same, more of the same. Is any of this any different? Well, number 9, we have 3 terms. So let's try, now it's not try 9. Let's try 13. I like that better. M minus 4 over M. Minus M minus 11 over M plus 4. Minus M minus 11 over M plus 4, I think. M minus 11 over M plus 4 equals 1 over M. All right, there she is. All right, so nothing to factor. So what do you need for our LCD? We need an M. Do we need it twice? No. The M appears in any one denominator is once. It appears once here, the most in any one denominator is once. So we need the M, and M plus 4 is a different animal. So there is our LCD. There's our LCD. So I need M plus 4 over 1 here. I need it here. Didn't give myself very much room, over 1. And we need it here. Okay. Cancel. M's are gone. Cancel here. M plus 4's are gone. Cancel here. The M's are gone. You notice the denominators are all ones. So you don't need denominator anymore. What have I got? M plus 4, M minus 4, minus M minus 11 equals M plus 4. A lot of stuff, still got a lot of stuff here. So next step is multiply it out. We'll FOIL this out and you get m squared minus 16. Distribute negative m squared plus 11m, m plus 4. Collect like terms here, m squared negative m squared cancel. So I've got negative 16 plus 11m equals m plus 4. Once again, the quadratics are gone, so you just solve that. I don't know what you get. How about m equals negative 2? Maybe positive 2. Let's go with positive 2. Yep, m equals positive 2. Great. Okay. I think that pretty much covers the idea. There's nothing different there. But let's look at what happens now when we have to factor the denominators. So this will be like your homework on page 6. And you have 1 through 10. Let me do one of them for you. This is actually number 6. So up to this point on page 5, we did this. We didn't have to factor all the denominators. At the first step, didn't have to do it. We had to find the LCD, multiply each term, cancel, multiply, solve. So of those 6 steps, we did 2 through 6. Now we're going to do 1 through 6. So step 1, factor all denominators. Good there. This factors into x minus 9, x minus 2, and we're good there. So now that you have that, what's your LCD? Well, how many x minus 9s do I need? Well, what's the most it appears in any single denominator? Once. And I need an x minus 2. So once you do that, now it's just like page 5. Once you have factored, found your LCD, it's just like page 5. So here we go. X minus 9, x minus 2 over 1 over 1. I've been using different colors, but there's some other stuff blocking it. So I can't get at those other colors. Sorry. And now we cancel. X minus 9s cancel. Here the x minus 9s. And that was an x minus 2. They also cancel. And here the x minus 9s cancel. What am I left with? 5, x minus 2, minus, everything cancels, so it's just a 1. And over here I have x minus 2, I believe. And just go ahead and solve that. Easy enough. Let's do one more of that type. Let me see if I can make one up here. Let's go x squared minus 9 there. Let's see, x minus x plus 3, x squared plus 4x plus 3. This will be good. Give me a second here. Can make this actually a 10. No, let's leave it. Leave it well enough alone. Okay. Are we ready to factor them denominators? X plus 3, x minus 3, 2, x plus 3, x plus 3, x plus 1. Okay. So once you've all done all that, what is our LCD? Well, if you see it, you need it. You see an x plus 3? Yeah, so you need it. You see an x minus 3? Yeah, you need it. You see a 2? Yeah, you need it. You see an x plus 1? Yeah, you need it. Question of how many do you need? What's the most x plus 3 appears in any single denominator? Once, once, once. So it's just 1. What's the most x minus 3 appears in the denominator? Once. We need a 2. And we need an x plus 1. Okay, big daddy LCD right there. All right, you need an x plus 3, an x minus 3, a 2, and an x plus 1. Let's see what happens with this. I'm going to group this. And I'm going to shrink it. And I'm going to shrink it more. I'm going to clone it a few times. Clone. And clone. Okay, and now so I can slide it right up through there. The beauty of the smart board. I'll put it behind. It really doesn't matter if it's front or behind. It kind of put it wherever we have room. Okay. All right, so here we go. What cancels? X plus 3 with X plus 3, X minus 3 with X minus 3. I'm left with the 2, and X plus 1 is 7. 2 times 7, 14, X plus 1. What cancels here? 2 with a 2. X plus 3, X plus 3. So now I have 3, X minus 3, X plus 1. All right. Equals. X plus 3's cancel. X plus 1's cancel. I have 2, X minus 3. All right. Now I get the step where we multiply, which might be a FOIL or distributive. 14X plus 14. Here I'm going to FOIL this first. I'll get X squared minus 2X minus 3 once it's all said and done. Now times this 3. So 3X squared minus 6X minus 9. And over here it's 2X minus 6. Okay. Well, let's clean it up. Let's collect like terms here. I got 3X squared plus 8X plus 5. Is that right? 3X squared, 14 minus 6, 8X, 14 minus 9, 5, 2X minus 6. We do, in fact, have a quadratic, and X squared that won't go away this time. So get everything on one side. I'll subtract 2X, I'll add 6. And let's see what we got. 3X squared plus 6X plus 11 equals 0. We got to solve a quadratic. Does that factor? Well, multiply to 33, add to 6. I don't think so. So it's quadratic formula. So just do your quadratic formula, and that's it. Okay, let's see if we can get one more. One more. Okay. Here we go. A minus 1 doesn't factor. 1 minus a doesn't factor. This factors into a minus 1, a plus 1. Okay, so what do we need for LCD? Well, we need a minus 1. We need a plus 1. But how about this 1 minus a? Well, 1 minus a is different than a minus 1. But watch this move right here. Multiply top and bottom by -1, which is legit. That would make this -5 over -1 plus a, which is a minus 1. So rather than adding a 1 minus a into our LCD, let's make this move. Multiply top and bottom by -1. And when I do this, that becomes -5 over -1 plus a, which is a minus 1. So let's just replace this with this. Okay. And now there's our LCD, a minus 1, a plus 1. Okay. And cancel time. A minus 1's cancel. 3, a plus 1. A minus 1's cancel. -5, a plus 1 equals, it all cancels. That shouldn't have been 2x. That's my bad. That should be 2a. All right, but you got this. There's no a squared. That's easy to solve. Okay, boys and girls. Well, that's how you do it. So I'll be posting this. Well, you already know that because you're looking at it. So do a good job on page 6, 1 through 10. I'll see you in class. I don't know, Thursday, Friday. We drop Friday, Monday, Memorial Day. I'll see you soon. All right. Thanks. Bye-bye.